Hi folks, and welcome back to another segment of Terminating Low Voltage Cables. I'm Ron with IDEAL, and again, welcome to my channel. Hey, in this segment, I'm going to cover the topic of UTP or category wire. That's your category 6 or 5E or whatever it might be. You know, and all these wires have some basic properties they all share. And I'll explain some of the differences in these cables, a little bit about the history, and we'll get into where you should use some wire, where you shouldn't, and a little bit about pulling the wire. And if I can get that done in 15 minutes, we'll be doing really good. So let's take a quick look at kind of what is available out there as far as recognized cables. And that's your category 5E, your category 6, and your category 6A. So let's take a quick look. When we take a closer look at the category cables that are available today, basically you have category 5E, Cat 6, and Cat 6A. And I'm holding a piece of typical piece of category 5E. And when you look at a piece of 5E wire, you'll find 4 pairs in the cable, and they're blue and orange, green and brown, and they're labeled. Pair 1's blue, and 2 is orange, 3 is green, and pair 4 is brown. And if you need help with color code configurations, refer to the video on my channel. And they'll be 24 gauge, twisted together at a certain rate. And then all 4 pairs are twisted through a certain rate throughout the entire cable. We'll talk about twisting here in a minute. Then we have this nylon, what they refer to as a ripcord in the cabling as well, and that's used for stripping the wire, and then an outer jacketing. And that's pretty typical of most of your category 5E cable you see. Now, the next cable beyond that is category 6A, or 6 I should say, 6. And when we look at 6, it's a little bit thicker in diameter, and partly because of the amount of twisting has been increased in the cabling. Also, besides having a nylon ripcord in the cabling, we would also have some form of a separator. And not all 6 wire has separators in it. A lot of it does. Some of it's the larger plastic splines than this little tab you see here. But again, this is kind of a representation of a typical category 6 wire you might see today. Now, the third one is 6A. And 6A is the latest and greatest as far as data networking cable is concerned. And you might notice it is significantly thicker than the other 2 cables. And the amount of twisting we're doing in the cabling is getting pretty serious as well. And then we'll also normally find some form of a separator in the cabling here. And this is a little bit bigger than anything you might have seen before. And again, helps maintain our twistedness between the pairs. And then again, we twist the 4 pairs at a certain rate and twist all 4 pairs together at a certain rate and generate a cable that meets 6A standards. Okay, so those are the 3 basic data networking cables you might run across if it's UTP wire, and hopefully you can then recognize them when you see them. And of course, they're marked every 2 foot along on the cable as well. So either way, you should be able to identify what you're working with. Now you've taken a kind of a quick look at the 3 basic category 5E, Cat 6, Cat 6A wires we have available in the industry. Let's talk about some of the similarities in all these wires. And when you look at category cable, as a general rule, you're going to find it's twisted. Obviously, you notice that when you look close up at it. And how we twist and how much we twist and has a lot to do with the cable's performance. A lot of us don't realize that all wires are engineered in a certain shape, and you mess with that shape, you kind of mess with the performance of that cable. So we don't really want to deform the shape of the cable. The shape of the wire, and untwisting of pairs is a big one. So why do we twist pairs? Well, we do that to eliminate what we call noise or crosstalk in cabling. And it's the big difference between old telephone wire and new wire is that we twist category cable. And I'm sure most of us in our lifetime have picked up a phone sometime, and you can faintly hear somebody else talking in the background. What's going on there is you got 2 telephone pairs sitting real close together. And anytime you put current down a conductor, it's going to radiate this thing called a magnetic field, which we call EMI. And this little wand here can pick up the noise being generated off this electrical wire that's feeding the light over here. So this EMI can be problems and interference with things, and that's what's going on. In old telephone circuits, that electrical noise coming from one pair to another was getting induced into the other pair, and you can actually faintly hear that other conversation. Well, obviously a computer can't have that, so we got to eliminate this in the cabling. So how do we do it? Well, we twist the wires. And when I look at how we send a signal down catenary cabling versus other wires, catenary wire is what we refer to as a balanced pair or balanced system. And in coax, the center conductor basically carried the signal, and the shield was our ground or zero reference point. And in catenary cabling, not quite the same. We're going to have 2 conductors that are going to make up this pair. And basically, we take a part of the signal and put it down one of the two conductors. And then we take a part of the signal, the other half, and send it down the other conductor. Now, we have means of basically controlling these magnetic fields. And these magnetic fields, when they emit off the wire, they're actually rotating in different directions, or can be. So this one, we'll make sure that magnetic field is going in a clockwise manner, say. And on this side, we'll make sure the magnetic field is going the opposite direction. Now, the two magnetic fields are equal and they're opposite. And as we twist pairs together in the cabling, obviously they will cancel themselves out. And the real big difference in all these catenary cables is how much twisting we're doing the pairs. And the more we're doing, the better it is. Now, if you were going to guess and ask, what is the number one thing we do not do to catenary cabling in the process of installing it, and if you said it was untwisting of pairs, it's the number one thing. And I tell you, when I look at a lot of new home construction, residential, I see a lot of 5E cables out untwisted actually quite a bit, and you know what, it's basically great phone wire at this point. So no good for data. Now, what is available cable-wise today? Well, the old red, green, yellow, black telephone wire, which we used for years in the phone industry, is basically no longer allowed out there. And we're trying to get rid of it. And you can imagine how much of this is out there. But and it's going to be around a long time. But where it's still used today is from the outlet in the room to the phone in the room, outside of walls. Actually, it's a code violation to put this in walls due to the type of insulation that's on it. It's not, excuse me, fire rated to go behind a wall. So the FCC back in July of 2000 basically outlaws that wire behind walls, and they tell us they want us to go to catenary wire. Now, catenary wire, and the first one out there was something called Cat3, okay? And Cat3 wire was the first real data wire out there, although today it's really regulated as to phone work by most of the industry. And that's what your phone guys will be carrying and using in most cases, but phone only today pretty much. And when we measure these wires, we measure the wires for a couple basic things, and one is the frequency range of the cable. Now, this is the size of the pipe, and this is how big it is, and the bigger this pipe, the more information we can pass through the pipe. But Cat3 had a frequency range for that system at 16 megahertz, okay, in frequency. Now, we also rate the cable for how much information we can pass through this pipe. And we did that, and we measure that, and we call it data, and we measure that in megabits. In this case, it was rated for 10 megabits per second, okay? Now, a bit to a computer is a 1 or 0, so it's working at 10 million bits per second. Now, Category 3 wire, when it came out, is really kind of meant to work with a data network system that was out there called Ethernet. And this was designed to support what we called 10 base T data networks, okay? Or Ethernet systems, okay? Which really became the hottest type of data system out there, okay? Now, Cat3, which was developed really back in the late 80s, and we used to think it was pretty smoking hot, but of course it's not anymore. And I mean, these systems are not getting any slower. They're doing nothing but getting faster. Cat 4 came out for a little while. It's dead and gone. We did come out with a Cat 5 cable for a while. And Category cabling, 5 cable, was brought out because we were coming out with a new system called 100 base T. Okay, now we call that Fast Ethernet. And Fast Ethernet needed a system that could support 100 megabits, okay? And we needed, a big enough pipe to do that, we needed a pipe big enough that was up to 100 megahertz in frequency. So the old Cat 5 was 100 megahertz at 100 megabits, okay? And supported old Ethernet, 100 base T, Fast Ethernet. Now, several years go on here, and one of the things we can do to make a cable better is there's a lot of things we can do within the cable as far as tweaking it and things like that, as far as the twists per inch, the type of insulations and things like that to make a cable a little bit better. And a number of years go out, and the industry then develops something referred to as 1000 base T. Okay. Now 1000 base T needs 1000 megabits per second. Okay. And our old 5 wasn't quite good enough, and the exact machine making Cat 5, we tweaked it a little bit better basically to make it 5E cable. So 5E comes out, and that means enhanced. But it's still rated at 100 megahertz in frequency. So it's 100 megahertz, provides us with 1000 megabits of data networking ability. Now, partly how they get faster is from here up, from 100 up, we use 2 of the 4 pairs in the cable to do the data network. With here and above, we will use them all. So that's partly how we get faster, is we're using all the pairs. Now, for a number of years now, again, this is fine, and nothing's faster than this in industry. And cable manufacturers, how could they make their cable better than somebody else's? Well, they don't have to make the cable to the standard. They can always make it something better than what the standard says it needs to be. And in this case, we were coming up with cable manufacturers making cable that's in the 200, 250, 300 megahertz frequency range, which is super duper fat Cat 5e back in the day. And you might have seen a 5 with a capital E on it, and that kind of indicated what it was. But after a few years, the industry says, you know what, a lot of people are making wire above 5e standards today, and it's time to bring out another one. So here comes Cat 6 wire. Now Cat 6 was still supporting 1000 megabits, so it still did this, okay? And we wanted, so we still need 1000 megabits, okay? But we needed a cable that's a little bit bigger pipe. So Cat 6 is tested out and to 250 megahertz in frequency, okay? So the pipe gets 2.5 times bigger, still supporting gigabit Ethernet, because basically there's nothing besides gigabit out there. There's nothing beyond that yet. Well, a number of years go by, as they say. And here just recently, in the last couple years or so, our 10 gig data network systems come out. So now we're at 10,000 megabits, okay? 10,000 megabits, or 10,000 base T. And again, we call that 10 gig. That again gives us 10,000 megabits per second, okay? Now, in order to do this, we now have needed another cable. We're going to double in pipe again. So the pipe is out to 500 megahertz now, and we call that 6A. And A means augmented in this case. E meant enhanced. So now we have a cable that will support the high end of data networking. And they're working beyond this for sure. And Cat 6, depending on the quality of the cable and the quality of the installation and the length of the runs, it will support 10 gigabit. To what distance, we don't know. You'll have to test it. But 6A is a cable designed for that upper end of the cable industry. And when you look at the cable differences here, basically from right here on back, this is all 24 gauge wire. 6A and 6 is usually 23 gauge wire. Partly because that bigger gauge gives us a little bit bigger wire, a little less attenuation or loss in the wiring. And just the physical twisting of the cabling, a little bit bigger wire didn't hurt none either. So gauge-wise, it's gone up. That's partly how it gets bigger. Now the twisting is crazy here in Cat 6, but in the old Cat 3 wire, you might have seen 3, 4, 5 twists in a pair per foot, depending on who made it and what they were doing. 5 was in the low teens twist rates. 5E gets into the high teens, low 20s in the twist rates per pair. Per foot, depending on, again, who's making the wire. 6 is in the usually mid-20s to low 30s in the twist rates per foot. And 6A is in the 40s and 50s twist rates per foot. So it's really, really twisted, and we really mean it donut twisted. So there you go. That is part 1 of the UTP basic cabling videos that we're putting together for you. And again, I'm Ron with Ideal Industries, and thanks for coming to another video, and we'll see you next time.